Welcome to the Time Variance Authority for all time, always. And also welcome to the last assignment of this semester, Assignment 8. This assignment will be focused on linked list. And for that, let me give you a brief overview of what it is you're going to be doing here at the Time Variance Authority. The first place that we should look at is the assignment PDF. So I'm going to give you a walkthrough about this and sort of show you where to start and hopefully where to finish, which is with a good grade in the class, right? So the assignment is themed around the Loki Disney Plus show. And so I went ahead and gave a brief overview of the secret timeline within the show. However, I would rather you watch a YouTube video that's embedded in the assignment handout campus page so that you can better get an idea. But otherwise, you can read it. And so basically, the sacred timeline is all about keeping a continuous flow of time so that the multiverse doesn't get created. And the TBA's job is to prune any branches that arise due to any Nexus events. And so the linked list is going to be basically your sacred timeline. And each node is going to represent a year in the sacred timeline. And each year is going to be connected to the next year following 1891, 1892, and so on. In addition to that, there is another variable within the node that is the number of branches, and you ideally want this to stay at 0 because we don't want any branching, right? We want to keep the continuous flow of time here at the TBA. And so this linked list is going to look really, really big, something like that, or even bigger. And so what you're doing here at the TBA is you want to automate the system of pruning these branches. And so Mobius here is going to spare your life because you were a variant, and he wants your help to do this. And so I encourage you to read the PDF and sort of follow the timeline, follow the narrative that I provided to you to kind of get you engulfed into the assignment. But basically, you want to automate the Minutemen's job. And so that involves detecting and pruning any branches that appear. To do that, you also need to create a way of making the branches so that you can simulate removing them. And so that's let's kind of visualize how that looks. So your sacred timeline, no branching. But then when you have a branch, it's going to look something like this. That is known as a Nexus event within the canon of the story here. And so a Nexus event means that something happened in your timeline that created an alternate universe per se. So now you're dealing with multiple universes or a multiverse. This of course is not something we want because we want to keep a continuous flow of time. And so you want to detect and get rid of these branches by doing something that is known as pruning them. And to prune a branch, I have a picture of that somewhere here. Here we go. So to prune a branch, what the TBA does is they enter the branch, they take away the variant, and then they put a special charge that prunes the branch. So we're not going to worry about the removal of the variant. We're just going to prune the branch as is to fix the flow of time. And so the way we will do that is we're basically going to eliminate that node and its following years, because once you create a branch, it could, it grows. And so you want to get rid of not just the starting point, we want to get rid of the rest of it. In computer science terms, we want to deallocate those nodes so we don't have any memory leaks in our sacred timeline. And of course, we end up with a happy single timeline, our sacred timeline. And the TBA's job continues to succeed and do that for all time, always. Okay, so let's kind of go back and sort of see the PDF and how that explains it. So first we give you some introduction, We tell you what the functions are that you have to do, and the main functions that you're going to have to do there are going to be, they're all going to be contained within 2 classes. It's all going to be one file, and the 2 classes you're going to be working on are node and timeline. Node is basically a node class for a linked list with the added except, and it's a singly linked list, and the one detail being the number of branches, which is an extra variable inside of that node class. The other class you're working on is the timeline, which represents the sacred timeline. And so for that, you're going to have to do a couple of functions. The first one is going to be your constructor, which is the one that creates the sacred timeline at the beginning. And basically the, sorry, I was just thinking about something. Hopefully I did that right on my code. Yeah, okay. I will come back to what I was thinking about. But yeah, so the input for your program are command line arguments that are going to define how big the timeline is, how many Nexus events there are, and the one I was just thinking in my head is the seed, so that your randomness matches my randomness, and the code creates randomness so that you can grade your assignment correctly. So anyways, the constructor is going to not have any of that randomness. It's just going to create the linked list of the size needed B, and you can see the details in it. The create Nexus event function basically creates that branch in the timeline, and for that you need to understand how are we going to actually create a branch. So a single next pointer in a singly linked list, how is that going to have point to multiple things? You might be asking yourself, like, what? It's a single pointer, it can only point to one place, right? And for that, we turn to He Who Remains, who can give us a thorough explanation of that, as you can see here. The big thing to point out is that this node right here is now pointing to 2 different nodes, which is the branch timeline and the sacred timeline, and of course the number of branches, which is 0 for every node that doesn't have a branch or a Nexus event, but increases to 1 for a Nexus event because now we have 1 branch, right? And so for that, I want to explain something that you know, but maybe you didn't think about applying to this. And that's what really kind of I enjoyed about making this assignment. I was like, I wanted to push the boundaries of what weird, nasty things we could do in C++ to get around that limitation of one pointer pointing to one thing. And if we think back, just think integers for a minute, forget about linked lists, think about an integer like a. So an integer a is just a variable, and we have an integer ptr, which is a pointer variable, and we can make that pointer variable point to another integer by doing something like ptr gets new integer, that dynamically allocates a pointer, and also we can do things like ptr points to an existing integer like a by using the address of operator. Yeah, so here's the other thing you can do with a pointer. So if we have our integer pointer again, you can also allocate a single 1D array, right? Yeah, you can do that. Now, the array is not going to be of pointers, because then otherwise you need a double pointer here, essentially. Misleading name, but 2 asterisks there. So, yes, a pointer can point either to a single member or to an array of members. And so we take advantage of that. And instead of having it, and well, of course, you might be like, well, okay, we make an array and each one points to a node in the a branch or a normal node in the timeline. But you can't do that because that would be a pointer array, and that would need 2 asterisks, and that would violate what we're trying to do. So they have to be actual array of nodes. They're not pointer nodes, they're nodes. So what is going to happen is we're basically going to make a little array here of size 2, and in one of them, you're going to make a brand new node, which is going to be the same year as the one that you're starting with, because that's your alternate year per se for the remainder of the year from the branching point, I suppose you could think. And then the other one would contain the next node in the sacred timeline. Now, the next node in the sacred timeline is a dynamic node, but because you cannot have a dynamic node there, because you can't point to anything, because it can't be a pointer, you have to make a brand new node as part of the array. It's the second entry in the array. Copy the contents over of this node, and then deallocate this node temporarily. So you are slightly tweaking the sacred timeline because you're duplicating the next year so that the system can work. But it's a small cost for us to be able to do the assignment well. So just because I want to emphasize that, I'm going to do a little drawing here. So if we take one of our nodes here, so we have a node, and this node is going to be the node where the Nexus event happens. Okay, and that's the node afterwards. So the year, let's just say it's going to be 1893, which means this is 1894, and currently there are no branches, and this node address is pointing, the next pointer is pointing to 1894. So now, when we say we want to make a Nexus event, this next pointer is no longer going to be pointing to this node. So we'll put this node to the side of it here, and of course there's other nodes to follow it. We make a little array of size 2, which is technically 2 nodes. So you could say that that node lives in there, and then there's another node as well. Actually, technically it would be the node up here. Now these nodes, again, you're not having pointers anymore. It's just an array of data. So if you think of integers, you're actually having the integers there, not pointers to where the integers are. So, yes, yeah, this is good. Okay. So taking the information from here and putting it here means actually copying each item. So basically just copying the year, copying the next pointer, so that way this now points to the next place, and then copying the branches of 0 there, unless there's an existing Nexus event there already, then it would be 0. And then this is a node that you're making brand new from scratch as well, which you're just taking the year. It's going to have 0 branches because it's already a branch. And the next pointer is going to point now to other normal nodes, so dynamic nodes within that branch timeline. So these are all going to be brand new nodes that are going to be made. And the number of those will be decided by a variable that's randomly generated, the number of nodes at least. Okay, so this is tricky. This is the trickiest part of the assignment, and it took me a while to get it working, especially because once you've made it, then if you want to remove it, so when you're pruning the timeline, you have to do this backwards. So let's do that now. So when you are pruning the timeline, and by the way, once you do this, you can just deallocate this node because you don't need it anymore. Okay, so that's one deallocation that you gotta keep track of. Although I personally, when I did this assignment, I actually just was like, you know what, I can't handle this deallocation stuff because I'm crashing a lot. I will worry about the allocation once I finish. So first I got the assignment fully working, and then I went back and I fixed all the memory leaks. And I found some errors in my code as I was fixing them. But sort of, that was the process that I took. So feel free to take the same process. Then again, when I was making the assignment, I was paving new road. You're just following the road that I paved for you. So it's a lot easier for you to do it than it was for me to do it, because I didn't even know it was gonna work. So your approach may be different than mine. But like I said, if you want to do it my way, get it working first, then worry about the allocation and memory leaks. But at the end though, no memory leaks allowed. So anyway, let's say it comes time to prune this branch, okay? So the first thing you want to do is locate the branch. So once you've located, because I guess we didn't do that, but technically this 0 should have changed to a 1. Let's break that up, that's fine. Would have changed to 1 because now there's a branch there. So we would look around the linked list. There's obviously things that come before it as well. And so we would be checking these numbers and finally see a 1 here. When we see a 1, we know that there is a branch going on there. So the first thing we do is we delete the nodes of the branch, like these ones. So deallocate those, or in my case, just cut it off just for a minute. But eventually when you get to deallocating, make sure you do deallocate them. And then from there, the next thing you need to do is you need to deallocate this 2D, this little 1D array of size 2. You're going to be very careful about that. Before you deallocate it, make a brand new node, dynamic, And that brand new node is going to represent the next tier of the timeline. So you're going to copy this stuff into the new node. So essentially, what you will end up doing, oops, hold on, trying to get it out of there, but there's like other stuff with it, so let's get rid of that. Yeah, okay. So you take this and you make a brand new node and you copy the data to it, okay? So that means copying the year, copying the next pointer, which I have ripped apart, spaghettified. Okay, so copy that next pointer. By copying that, I am now linking to the sacred timelines, year 1895. So now that's linking there. And of course, copy the branches as well. Okay? It's possible that you could have two continuous nodes that have branches coming out of them. I think in one of the sample codes that might be the case. And once you do that, once you copy those things, now you can go ahead and deallocate this to the array. Last thing, I guess, before you do it though, when you create this node, you probably have it on a temp. So just copy that temp information to that node before it. So you make that link. Very important. Very important that you make that link. Otherwise, the sacred timeline is broken, and he who remains will not be happy. So yes, then you can go ahead and get rid of this. And now, even though it looks kind of messy, we have restored the sacred timeline. So the reason I took a little bit of time for this is because it's the trickiest part. Okay? Everything else is piece of cake in my opinion. So yeah, this is me explaining all of that. The prune function is going to be the one that does the pruning, of course, which is what I just did there, which is the reverse of the creating the Nexus event. The create Nexus event function, you pass in a number of Nexus events you can make. So you can make more than one Nexus event. And then the prune function's job is to delete the next event. And then the main function runs it on a loop, so it deletes one event at a time until there's no more events to delete, basically. The print function is just going to print out the sacred timeline, and I'll show you how that looks like in a minute. And the vprint is another way to print the sacred timeline, or any branches too, by the way. It's just a visual version, okay? So there's your prune. The destructor deallocates, so once the program finishes, you can expect the timeline to always be pruned. So you don't need to worry about deallocating branches at that point. There is a cout statement that checks if there are any. That should never print out though, but have it there. It's a good way to debug your program to make sure that all the branches were pruned properly. But yeah, you don't need to have logic in there to deallocate any leftover branches, because that shouldn't ever happen. There is one more function that's called WTF. This function is actually the same as the print function, and I was kind enough to do it for you so that you can print your current status of your code, your timeline, because what I did when I did the assignment is I first made a print function. I needed to visualize what was happening, to fix issues that I had, to get it all working. And so I was like, well, let me give them a fully operational print function that literally should be the exact same as the print function that you make, but if I give you the code, then you're just gonna copy paste it and cheat. And that's a no-no. So I obfuscated the code so it just looks like a big mess of just nasty code, which is to be expected, so that you can't just look at that and copy it. And you cannot call my function from your print function either. No, the TAs will look at that. They will not be happy if they do that, if they see you do that. That would be considered cheating. So the function is just there to help you locally, without checking with code grade, see if your output would match my output and the code grade's output. Okay, so that's a very, very useful function. That's just there to help you match it and to test your code as you develop it, because you may not want to do the print function first. Okay, the main function is given to you. It's all hard-coded in, and you don't not touch at all. You can touch it while you're developing to tweak and fix things, but when you submit the assignment, that should be identical to what we have. And the 4 command line arguments are the seed value. That's what I was thinking earlier. That's because we want to make sure we run it with the same seed every time so that the output matches my output and so on. And then this is the number of Nexus events to create. And then the timeline, because we don't want to have a timeline with infinite amount of years because it's too much to draw on the screen. We want to have a starting year and we want to have the number of years. So 50 years is good just for testing purposes. I think the biggest one we run is 200 years, but you can run any size you want. I recommend you start with a small size where you're testing and getting things up and running. There's also a default, which means if you pass no command line arguments, that it'll run that default. And I think actually these are the default numbers too. So that's what a.out would actually be. Again, to make your life easier when debugging it, so you don't have to tweak around your IDE to get command line arguments working. Okay. There are two spots in the code where srand is used. Or well, actually, I guess srand is just once in main to initialize rand with a seed value. And then there's two places where I call rand function, which generates a random value. And both of those are given to you in the skeleton code. That way, you do not call them in the wrong spot and your randomness doesn't match my randomness. So if we take a quick look at the skeleton code, I'm just going to show you where they are. So they are actually going to both be in the create Nexus event function. So in there is one for the size of the of the branch that, or actually sorry, the first one that you see is to pick a year within the timeline that the Nexus event should happen at. So where in the timeline? It should be random. So that is going to pick it based on the current size of the timeline. So that's the first one. The second one is going to be the size of the branch. So the branch, you know, in the canon, the branch starts small and grows. Here I just decided that we're going to pick a size and it's just going to be different every time, and it could be big or it could be small. Because I didn't want to keep it that big and make it slightly canon, I went ahead and randomly generated based on the current size left for the remainder of the timeline. So if there's like 50 years, but the branch appears in year 40 of the 50, then the biggest it could be would be size 10. That way we don't have issues when printing and other nastiness. However, because I didn't like how big the branches were looking, I actually just divided by 4. And so it keeps it somewhat small, but it's still random to a degree. So that's all given to you. So don't touch that. If you touch it, it's going to break it, okay? So just let those be, write the rest of your code, but let those two function calls be, or sorry, those two rand calls be, so that your randomness matches my randomness, okay? That's the only important thing that you have to be careful about. Everything else, you can see the code given to you and also comments where to write your code. By the way, this is the obfuscated print function. So you can see it's very obfuscated. So that's the skeleton code. And now I would like to show you what the output looks like, just so you get an idea. So this is what the output looks like. I am running it with that same data. And you can see that I'm running it on Valgrind because I want to check for memory leaks. So first you get the word secret timeline printed out with the current status of the timeline. You can see that each year has an arrow following it. There should be about 50 of these because of the parameters. Then we have some output for the Nexus events that are randomly generated. And they're printed to you so you know for debugging purposes. But your prune function should be able to find them using the integer branch when that's not 0. And then the timeline gets printed again with Nexus events. The Nexus events are printed with little parentheses. So this is a Nexus event and it's printed with asterisks before each of the branch years. So you can see that it starts at the same year as the original time branches. And again, it's wrapped by parentheses and there's a curly tilde, there's a tilde for the next arrow after the parentheses. So that's another thing to keep an eye out for matching the output. And within it, it's just normal arrows, okay? So the differences are, for a normal year, you just have normal arrows. For the branch, you put it in parentheses, you put all the years there. The first one should always be this one. The 0.1 represents that this is the first branch that you're having at that year. The code that I wrote supports multiple branches within the same year. There's no test code given right now that does that to you, but you should still contemplate and make sure it functions in case we decide to test your code for that. And like I said, little tilde once you go back to the sacred timeline. And you can see there's multiple here. So here's one that only has two, size 2, right? So 2001, size 2. You can see that these are out of order because it's randomly generated. So this is basically the result of the RNG. This right here and this right here. Okay? So that's print for you. vprint is this one. It's a visual printing. So here's your timeline. This is always going to be maxed to this size. If the timeline is bigger, it just cuts it off. It does not print it. And each of the little dashes represent a year. And then whenever there's a branch, it happens right there. And of course, I just draw 2 lines like this to sort of show the branch visuals so it matches the show. And then the number of lines here, tildes, represent the number of years in that branch timeline that are randomly generated. So again, if you look at 2001, that is probably this one. So you can see that it's size 2. So that's why there's 2 there. And this must be probably 2001, this right here. That's why it matches that. So the location is correct, but it's based off of this point here. And again, it's always going to have 2 of these. So don't count this in the total. You can see there's a 2017 here. You can see 2017 here. So like there should be 2 more. So that's 18 and that's 19. So this is 17, and it right exactly beneath it is that point. So that means that actually this should be 2001, and this should be 1976, and this should be 1970, or sorry, 1975, and the one next to it is 76. Because here you can see there's actually 2 Nexus events that happened in subsequent years, 75 and 76. The way you draw this is you draw 1 branch up, 1 down, 1 up, 1 down. That's how you do it, just to make it easy to visualize, because otherwise they overlap. And you could have, I could have made more complicated logic to draw around this, but that's not the purpose of the assignment. If they ever overlap, by the way, because like this is really long and there's another branch here, that's fine. Just let it be. Here's you detecting a branch. Each time the branch gets pruned, it gets printed again, so 1 less Nexus event. So this is going to run 4 times because there's 4 of them until finally it doesn't find anymore, and then it says that the secret timeline has been restored. You can see in the main, that's basically what the code does. There's this function that's running multiple times, and when the function returns a -1, it means that there's no more branches to prune. So then it gets out of the loop and finishes. And then it prints out the secret timeline 1 more time. And this should be what it looks like, because there should be no more branches, otherwise you have issues. And of course, we want to print out our super cool TVA logo, which I manually drew. So there you go. You don't need to do that. I did that. So now let's go ahead and look at the canvas page so that you have a better idea. So the canvas page, you will see the glorious TVA logo, which I'm very proud I drew myself. So that's why it looks crooked. This is the video that I would encourage you to look at if you don't remember episode 1, season 1 of Loki, or if you just want a refresher. It's 3 minutes long. This is where the video I'm recording is going to be. This is a little placeholder that I teased on Discord. Here's your skeleton code. Here's your PDF file. Or sorry, no, this is your PDF file. This is your sample output. So let's take a look at sample outputs really quickly. That's not sample outputs are going to be things you can use to test with, and that's I think what CodeGrid is testing with. So sample output 1 does not have any input. That's because it uses the default parameters for the command line arguments. So it's basically the one we just looked at, actually. Sample output 1 is slightly different because it has a different seed value to it, and the different size, I believe, on the timeline, and the different number of Nexus events. So this first line tells you what the input should be for the output that you see here, okay? That one's going to be sample output 2. Sample output 3, same thing. So here's the input, this is the output. This is a small one, good for testing when you're starting out. Sample output 4, you don't see the command line there because it's actually under the Valgrind one. I just wanted to have it clean so you could do a diff if you want to check it. But this is what the input for that should be. So that's what 4 is. Okay, so it's under this file. It's not there, so just keep that in mind. Okay. Finally, we have sample output 5, this one. That's just another example that I have there. And then I have two Valgrind sample outputs. So Valgrind sample output 4 matches sample output 4. That's why I said this is there. And I manually copied the little background stuff, and you can see at the end there's no memory leaks, 0, 0, no errors either, and all matching the Alex and freeze. Okay, that's what you want. And the same thing for this one, which is using this input, which matches the one from this one, the default one. Okay, so those are the sample outputs to help you test your code, and those are found here under this zip file. It's not no password or anything, and that's pretty much it. So that is going to be the assignment. So I hope you enjoy it. I really liked doing this assignment, and kind of been watching this series. So this assignment should be released about the same time that the season 2 finale comes in. But this is focused on the first season because I didn't want to spoil things if you haven't seen the second one, because you might be busy with exams, right? So yes, I thank you for watching, and I wish you the best with the assignment. After all, we need to prune those branches and maintain the sanctity of the sacred timeline for all time, always. Have a great day.